Alright, so today I am going to be teaching you guys how to do horizontally launched projectiles. So I've given you a sample problem here. So a piano is thrown horizontally with an initial velocity of 26 meters per second from a height of 7 meters. So basically, horizontal launch projectiles are just um, projectiles going at a trajectory of 0 degrees. So it's basically just you throw an object off from a building and it's just gonna fall down at a curved path. So here we have a piano and we have the initial velocity of 26. So we're gonna have to list down first. First we visualize the problem. So I'm going to be listing down the given here in our illustration. So dy is 7 meters and VIY is 26 and oh wait, VIX is 26 and VIY is 0. So how do you remember if it's VIY and how do you not get confused? So basically um the reason why it's 26 meters because it's going from here to here, and VIY, it's basically, if you think of it as this, if this is the peak and then it's going down, then VIY should be 0 because that is the peak is always 0. Alright, so now how do you solve for all of these questions? How long? That is basically saying what is the time, and from this you just have to memorize these formulas, which is not that hard if you have mastered kinematics. We basically just derived all of these. So t equals square root of 2 dy equals g. So we're going to be solving for that. 2 times 7. dy is our distance on the y-axis, which is 7 meters, over g. And g stands for the gravity, which is always going to be 9.8 meters per second squared, unless you're somehow on another planet, but we're just going to be using that. So 9.8 meters per second squared. Alright, so how do you, you're just going to calculate this, use it in a calculator. So the answer would somehow be 1.20 seconds. We cancel out meters here and the square root here from the square, and that will give you 1.20 seconds. Alright, for the dx, what we're going to be doing is use this formula, these two. So we only have VIX right now, or actually VIX is equal to VFX because it's just on the same plane. So all we need to do is substitute. So if we want to answer dx, because that's the second question, how far is the piano from the launching point? So it's basically saying how far this is. This is the dx. So dx equals 26 meters per second times 1.20. So you should always try to find time first because it is going to be useful in finding VFY, dx, dy, and basically everything. So 1.20 seconds. And we put that in a calculator and it should give us 31.20, around there, 31, and we basically just cancel out s here and yes. Now for the third question, this is going to be easy as well. How fast will the piano go as it strikes the ground? It's basically saying what is the final velocity, which is here, this area, because VFY, if you learned from kinematics, it is the distance over time, right? VF is distance over time. So we've traveled a couple of distance here, and we've also had the time it took. So we're just gonna be using GT, this formula. So VFY equals, now VIY. What can you say about VIY? I already put 0 meters per second because we're solving for the y-axis. That's how it's basically like free fall. So 0 meters per second. So we just cancel that out. So all we need to do is add it negative 9.8 meters per second squared times 1.2 seconds. So that should give us negative 11.76. So I'll just put that in, 11.76 meters per second, because you cancel out the s here. Boom and boom. So that's how you got negative 11.76 meters per second, dx and t. So that is pretty much it. If you want a proof that this is right, I'll just send this. So as you can see, it is at initial speed of 26 meters and 7 meters high. So the time is 1.19, but it's basically the same. There's just some rounding off there. And for the range, 31.06, ours is 31.20. Now there is also some rounding up issues, but it should still be the same. Now we can't really check for the VFY here, but it is roughly this, 11.76 meters.